around, and if there's someone who's looking down, just give them a pat, give them a hug, give them a, hey, happy Friday, we got this. And let's start in our groups. Just say, hey, happy Friday. Give each other a high five, I don't know, something positive, a handshake. Just be like, we got this, let's go. And
Happy Friday.
here we go. Let's start with number 2. You guys ready? Alright. Thanks for checking in, guys. You can do that every day of the week. Go figure. It would be really encouraging and a blessing. Just, I don't know. Sometimes God blesses us just when we look around and try to bless others, ironically enough. Number 2, can you guys see the answer? Letter A, the final answer is -1/2. Letter B, the answer is -1. Now we're going to number 6, which is just a little bit lower. Oh, it didn't unfreeze. I apologize. Number 6. That was a pretty easy power rule, right? 12x to the 11th. 12x to the 11th. Next one. Where are we going? 14. It's right up here at the top. There we go. 2t minus 3. Ooh, what was different in that one? Can we still take derivatives when we have t's instead of x's?
No.
And the answer is yes. Do the rules change?
No.
No. So all we have to do is just use the rules that we know, whether it's an x, whether it's a t, whether it's a p, q, r, s, doesn't matter, right? What's next one? 18. Oh, you guys can see that one too, huh? Number 18, just with x's, you guys had a sum and difference. Final answer is 6x squared plus 12x. What's next one? 26? Okay, hold on, let me go find that one. 26. You guys had a few different ones. This was going through that table that I showed you in class, right? Of rewriting, then deriving, then rewriting yet again. Okay, what's the next one? Do you guys have a few in here?
28 and 30.
Okay, did I give you all of those, 25 through 30?
Yes, ma'am.
Okay, that's good to know. Thank you. All right, go ahead and keep checking them. All right, once you guys get past those, you should be pretty close to being done. What's our next even?
36.
Okay, that one has a trig function. Did anybody figure out why I say in calculus, and hopefully you figured this out earlier, but why I say you have to know your unit circle? This is a very basic example, but did you have to know the rule to take the derivative, to do the calculus? Yes, but what did you need to know to finish unit circle pre-calc? Okay, so that's a great example of what I've said as far as you need to be able to know your unit circle, because what if you know all the calculus and you just can't finish it? That's killer. Okay, next one.
All the way to 70.
All the way to 70. Man, having too much fun now. But our next even though is 70. Let me give you a second. This one's a little bit more involved.
Oh, she was wild.
Okay, number 70. What were the directions? You guys have it before you, right?
Yeah, they want you to find. They want you to find the value of k so that a line is x given, so y equals -2x plus 3.
Right.
Is the derivative? No, the tangent line.
Oh, got it. Okay, there are a couple different ways of doing this. I'm not exactly sure if I would have done it the way they did, to be completely honest. But they give you the function kx squared, and they want to figure out when or where that will be the tangent line, something like that. The k value. Okay. This is the tangent line, true? This is the tangent line. Now, they went ahead and set the equations equal, which is technically true, because the tangent line has to hit this curve, which means the y value of the tangent line has to equal the y value of the curve at a point. Okay? So what we're saying is the tangent line is going to hit this curve at one point. Their points are going to match somewhere. And think intersections, we set two graphs equal to each other to find their intersection, right? Again, from algebra or from pre-calc. We're trying to find an intersection, we set two functions equal to each other to find the x. So one way is to say, hey, these two intersect. The tangent line and the parabola, they have to intersect at one point. That's the definition of the tangent line. But what happened here? They're not solving in this one. They're making two different equations. What's happening here? They took the derivative and they said the derivative is going to have to equal. Now, you could take the derivative of this side, or you could just say this is a tangent line. I know the slope of the tangent line is the derivative. But either way, you can derive both sides, or you can say I know negative 2 is the slope and set equal to the derivative of 2kx squared. Sorry, of kx squared. Why is the k just chilling in the derivative?
Because powerful, it's a scalar multiple, so you
Good.
don't know.
It's a constant, so the constant's just chilling. Like if it was a 3, the 3 would stay. If it was a 4, the 4 would stay. So we just bring down the 2. The k is the constant multiple, or the scalar multiple. So I'm able just to keep that k there. So that's the derivative. At which point they just go ahead and solve for k, and then they had another equation. So what they do, plug in and then solve for x. And once they found x, they were able to plug in and solve. Could you have also just solved for x and plugged in for x and found k? Yeah, you do it either way. But long story short, you have two equations, it's a little baby system. They use substitution, solve for one, plug into the other, solve, solve, solve. Your final answer, k equals negative 1/3. How many of you guys had a question on that one coming into it? Yeah. Okay, at least a few. It was a hard one. Okay, any other evens?
110.8.
110.
Another one like
Ooh, it's a piecewise. Is that the whole thing? I think so.
yeah. She was jealous.
It's okay, she's just a little spicy. Right? Oh, I don't like the spice. Nope. Is that the end? Okay. Alright. 110. Let me actually come back here really quickly, make it a little smaller. It's a little too big. Okay. Piecewise function. Did they say it was continuous or that it needed to be continuous? Needed to be continuous. So before you did anything else, what are they doing if they're coming towards 2 from below the f and from above the f? What are they doing? Defining the limit from below and from above, and they're saying, you know what, the one-sided limits need to agree. See what they did? So took the limit from below by plugging into the below piece, took the limit from above by plugging into the above piece. Remember, this is just an x, so it only gets plugged into the x spot. You have two different expressions for the limit from below and from above. They need to agree. What's the dilemma though? How many variables are in this equation? So we have to know that there's another clue. P.S. If I were you with your colored pen, put a little star by this one. This is a great AP question. It would be a multiple choice, but it's a great AP question. Okay? Because you needed to do two things. You needed to check out continuity by plugging in the top piece, the bottom piece, setting equal to each other. And you also need to make sure it's differentiable, which means, okay, ready? Piecewise function. How do we take a derivative of a piecewise function? Piece by piece. Derivative of the top, bring down the 3. The a is just a constant, so 3ax squared. Derivative of the bottom, bring down the 2 powerful, which is going to be 2x. What's the derivative of any constant? What's the derivative of b? 0, which goes away. So now I have a piecewise derivative. Now, is there an equals to? Because the derivatives need to agree for the derivative to exist, since it's a limit, at 2. So we have to check and see if they agree. Because if they don't agree, then I can't say are equal to. And right now, there is no a in here. So right now, it's only going to agree for one value of a. It's going to disagree for the rest. So they say, okay, these are all the derivatives below. These are all the derivatives from above. They take out the or equals to because we have to make it match to be able to put equals. Now, the nice thing of the problem is they say you make it differentiable. You make these two match. You make the derivative at 2 exist. So how do you make it exist? Go from below, plug in. Go from above, plug in, hey, so it's the same process, just this one's plugging into the original to make it continuous. This one's plugging into the derivative to make it differentiable. So then they plug in and set equal to each other. You're able to solve for A, and once you have A, what are you going to go do?
Plug it in.
Plug it in and solve for B. So continuity says make the two pieces of the original function match. Differentiable says make the two pieces of the derivative match. Does that make sense? Sure. Oh, because A right now can be any number, so we're not guaranteed that these two will match. And if the derivative, if the slopes do not match, remember they clash. If the slope from one side does not match the slope of the other side, then the derivative does not exist. So they have to keep the equals off because there's no guarantee that they're going to match.
So every time you're doing the piece
A derivative, take the equals out. Then you have to check. On this one, we went ahead and kept going, and we found the 1A and the 1B that would make it continuous and differentiable. Okay, but if A was anything else other than 1/3, the derivative wouldn't exist. Does that make sense, kind of? It's a little weird. For continuous, the original function, both sides have to agree. Differentiable, the derivative, both sides have to agree. And pause. In order to be differentiable, not only do the two sides need to agree, but doesn't it have to be continuous to begin with? So we had to make it continuous in order to even let it be able to be differentiable. Because if a function is not continuous, what's for sure going to be true? It's not differentiable. Forever card number, I don't know, something or other. Yeah, that one. All right, kiddos, do we have any other ones, or is that the last one?
That was the last one.
All right, I'm going to go back to the homework assignment really quickly. Were there any odds that we got stuck on? You were able to check CalcChat. You guys, remember the pink ones? You can watch the videos how to solve, right? Okay, you can get the download the CalcView app. Is that what it's called?
Yeah.
The CalcView app. You can scan the QR code; it'll go straight to the video for you. But if you don't have data, then use a computer or Wi-Fi. Okay, let's go ahead and close up our spirals. Let's go back to notes. I'm going to go ahead and save this really quickly for period 6. Thanks for letting me build the homework solutions this year. You guys let me do it in pre-cal last year, and now I'm doing it in calculus this year. All right, cool. Yesterday, what did we talk about?
Rates.
Rates.
Oh, average rates.
Rates. Wait, is this? Oh, this is pre-cal. I'm like, why is it all filled in? That's not right. Okay, sorry. Hello, Santo. Okay, here we are. This still isn't right. Struggle, where are you guys?
It's honors pre-cal.
Oh, here you are. You're the one that starts with, okay, I got it, I'm tracking. Okay, run rates. Pause. Guess what? In period 6, we figured out that you guys are wrong. And I don't know why, but you're wrong with your average rates. The first one is right, and the second two are horribly wrong. So, I have it in my calculator, I think still stored from yesterday. Let me show you how to use our calculator to do the average rates. Because if we're allowed to use our calculator, man, this sure will speed things up. Do you remember where I put this function yesterday in my calculator? So I can refer to it over and over again?
Y1.
Y1. If I put it in Y1, I can refer to it using these things called Y bars, right? If you guys brought your calculator today, it'd be a great idea to grab it out and just make sure you know how to follow along. So I know, right? I have Y1 in my function. Double check, it's a negative 16. T is just an X value. X squared plus 150. How am I getting all of this snazzy stuff for solving this one? Let's go up because we're actually doing the 2 and 2.1 first. Where am I getting all this notation? Do you remember? Nope. Okay. I'm going to hit the equals. So first of all, our answer is not negative 16. Oh, bummer. Our answer is negative 75.6, which is actually going to make a lot more sense in just a second. Because we went on to go ahead and find the instantaneous velocity. We'll get there in a second. But let's come back to our calculator. Okay. If you hit alpha y equals, as long as you have a calculator without a yellow button, you can make the nice pretty fraction look like what you want it to be. You can get a nice pretty fraction. Now, if you have a yellow button, you can't do that. You're going to have to put big old parentheses around the numerator a division sign and big old parentheses around the denominator. But how do we get what to do in the numerator? There's always, for any calculator, you can hit the vars button, you can go over to y vars, you can hit enter with function, and you can get the y1. With any calculator, you can get the y1 by hitting vars, going over, hitting enter, and then you'll see y1. Vars, over, function, y1. I'm going ahead and plugging in my, well, I already did 2.1. Let me plug in the next one, 2.01. However, the newer calculators, kiddos, where's that shortcut? What can you do?
Alpha trace.
Alpha trace. I'm sorry, yesterday I kept on saying window. I didn't have the calculator in front of me. It's the fourth button over. Or you can do alpha y equals, get to the F1s, and go over and hit F4, because you're actually doing these green buttons. You can get y1 that shortcut way, and you can do y1 of, for instance, 2. It's just like function notation, f of 2.01 minus f of 2, all over 2.01 minus 2. Okay. So then I get my second answer of negative 64.16. Makes it a little bit easier than having to like type this in and trying to do it 2 different times and do a subtraction and division. Anyway, it's safer. It's safer if you are using your calculator to put it in all at once. Once again, older calculators, you have to type this in with big old parentheses, then do a division, and then put this with big old parentheses. So this one we get to be negative 65 point, did you guys get it? Was it 6?
Yes.
And then negative 64.16.
Yes.
Why is it feet per second?
Because it's distance over time.
Yeah. Isn't the top stuff, these are positions? And positions are measured in feet. It's the height. And then the bottom are times, and times are measured in seconds. You can always do that. Match up the units with the quantities in the equation.
You want to know why we were horribly wrong? Because I had 16x, not 16x squared. Yeah, what's Thomas?
It's okay, he's being home. He's being real. That would do it. That would definitely mess it up. Because the derivative of negative 16x would be negative 16, so it's always constant. Coming down. So these are average. Remember yesterday we were talking about the radar gun? What's the radar gun trying to do? Get your speed at 1 instant. As opposed to like, hey, you're traveling for this amount of time. This one, there's a whole second, which doesn't seem like long. But a whole second. That we're just taking the average of all the different position changes over all the different times. Negative 80 is a lot different than, oh look, if you just do between 2.1 and 2, between 2.01 and 2, and we talked about yesterday, what am I doing? I'm approaching the instant of, can you tell? I started from 2 to 3, to 2 to 2.1, to 2 to 2.01. I'm approaching the instant at 2 seconds.
Oh, you're approaching it.
Yeah, does that make sense? Exactly. So I'm using the averages to approach the instantaneous at 2. And how would I find the instantaneous rate or the instantaneous velocity at 2? Take the derivative, and who's the derivative of this guy?
That guy.
Oh, come on, do it right here, do it in your head. Bring down the 2, negative 32 t to the 1, and then what's the derivative of any constant?
0.
0. So the derivative is negative 32 t, and to find at the instant of 2, all I have to do is plug in. Does it make sense, these numbers? That negative 64 feet per second would be at the instant. Yeah. But what would you rather do? One derivative and plug in, or all these different averages to try to see what's approaching?
One, please.
Which is very similar, remember, to our group activity of all the different secant lines, getting the tangent line? It's easier to jump to the tangent line, and we can do that with calculus. But the slope of the tangent line corresponds to the instantaneous velocity, because both of them use the, who's this guy?
Derivative thing.
Yeah, the derivative function. Okay, so instantaneous velocity, instantaneous rate, that's the derivative. But how would you do it without a derivative? You would need 2 different x values, 2 different, like an a and a b. You would need to plug in and get your change in y. Change in y over change in x, you're doing slope the old-fashioned way. And remember, instantaneous, or I should just say rate in general, is slope. We did not actually write that in class yesterday, so can we go ahead and do it really quick? Rate is a slope. So on a graph, we could be talking about a slope, but in a motion problem, we could be talking about rate. And the slope on a graph can actually find the rate of motion in a word problem. So they correspond in a way they're synonymous. Does that make sense, kind of? Okay. You guys write down slope? Sorry, did you just write down slope? So rate is slope. Okay. So we talked about average, so instantaneous. We solved it in the last problem. Let's go ahead and write it. To find the instantaneous velocity, the radar gun. How fast are you going at an instant? Once again, I have not necessarily looked into the technology or into the hardware of a radar gun and the programming of a radar gun as to how it works. I bet it does a change in, but it does a very, very slight change in so that it has a pretty good idea of how fast you're going. Let me tear something. But instantaneous velocity. Find the derivative at a particular x value. So, I'm going to change this really quickly. If we're talking about motion, it's not going to be an x. The x's are going to be, did you guys catch it? T's. The x's are going to be t's. What am I don't even know what I'm doing. Struggle. There we go. The x's are going to be t's. So, we could say that v of t, velocity at one time, is equal to x prime of t. Or, remember yesterday I said it could be written x or s, and technically if you were doing vertical motion, it could be even y of t. S is kind of just a general, like, the position function in a rectilinear model. But they could say x if it's horizontal. It could say y if it's vertical. Once you get to physics, you can kind of figure out that you can make a vertical and no horizontal. It doesn't really make a difference. Instantaneous velocity. Average velocity, we need a slope formula. We need to go ahead and take a change in. A change in y's over a change in x's. But instantaneous, just take a derivative and plug and change. And that brings us up to a nice word problem. You ready? Oh, come on, it's okay. We'll work together. But first.
How much of the word problem would you like us to write?
Well, let's pause and think of last year. You guys probably don't remember all the inverse direct variation in that whole crazy word problem homework in section 1, chapter 1, section 10. But last year we talked about how if you're writing down the information from a word problem, some people are like, I want to write down word for word because as I start translating into math, as I start narrowing it down, I tend to miss and I tend to leave out things. So if they write down the whole word problem, they're like, I'm not going to leave anything out, I'm going to have it all here. But other people are like, no, I'm super careful. And when I write down the important information, I get it all. Does that make sense? So, can you summarize the important information? Yes. Is that a good skill to be able to read something that's kind of long, maybe a little convoluted, and pick out the most important stuff to use? That's great in math, that's great in physics, that's great in English, that's great in reading comprehension, SAT stuff, that's great all over the place. So, do I mind if in homework you go ahead and tell me basically like a 1 or 2 word what the problem's about, and then give me all the key players and all the key information? I don't mind, that's fine. Don't write any words. But if you're like, I leave stuff out, maybe you should make yourself write the words until you stop leaving stuff out. So it's up to you. But make sure when you write down things, make sure you write down units, make sure you write down the key players as far as the key quantities that are in play, and make sure you write down the question. Because you have to make sure at the end of the day, have you answered what's been asked of you. Does that make sense? So here we go. Woo! What are you going to call this one? Water balloon problem, right? Water balloon, period, if you're summarizing. Water balloon, period. Yes, a sketch can sometimes help you summarize the information. A water balloon is thrown upward from the top of an 80-foot building with an initial velocity of 64 feet per second. The height s in feet of the balloon can be modeled by the position function s of t equals, physics people, maybe you can know where this equation came from, negative 16t squared plus 64t plus 80, where t is the time in seconds since it was thrown. Since it was thrown. Sorry, I had the wrong intonation there. So, those of you guys that are summarizing, what have you written down so far?
Up a foot, and the initial velocity is 64 feet per second. S equals height.
You just
and
draw a
the
picture of a
equation.
building.
You can make it, that's really messy. 80-foot building. Is it a right-left model or is it an up-down model? Up-down. We know the initial velocity if you want to do it this way. No, I don't like that. You could almost do a little vector and then put down 64 feet per second. Could almost do that. What I would do instead is I would name it V of 0. Snazzy notation for V of 0 is V sub naught. I know it sounds weird. The V sub naught is V with the subscript of the 0, indicating it's at the beginning, or it's the initial, which means time is equal to 0. And we know that's equal to, now, pause. Does velocity take into account direction?
Yes.
Yes. And where is this balloon headed?
Straight up.
Going straight down. So if it's going down, what sign should I add to the magnitude of 64 feet per second? Exactly. I need to put a negative 64 feet per second because it's headed downwards, and velocity says I want the down, negative, and the speed, 64.
Isn't the ball thrown upwards, but the acceleration is in the negative direction?
Oh, I didn't even read the phone. I did, but I totally ignored it. Initial thrown upward. Thank you, thank you, thank you. I was seeing it thrown downward. So what do I need to change?
Well,
And then
what,
So
you just
what-
need to
so when just
So what do they do?
positive
Take out
64.
Keep it positive.
Keep it positive.
Yeah.
And then if it's all
Miss T, is gravity,
So up on the
is
edge.
gravity,
If you like hold it up. Hold it up.
Alright, hold on. I'm hearing some good questions, but pause. Tyler brought up, see, struggle of summarizing. I left out a clue in my own head. I saw it as throwing it down. If it was throwing it down, that would be negative 64. But is that different than throwing it up and having it come back down? Now pause. I'm on the edge of the building. There's a railing. I'm leaning against it. I throw it straight up with my arm extended, and what's it going to do? Come straight down. We're not thinking of wind. We're not thinking of like throwing it in a curve. We're just saying we're throwing it leaning off the edge of the building with a railing, because I'm being safe. My arm extended. I'm throwing it straight up. It's falling straight down. Okay. Now, is that real life?
No.
Could be.
I'll do it.
Could be. But
Let's do it right now.
could no, there's no railing. I'm not going to. Well, it'd be fun to be up there, but no. Because real life would probably be you're throwing it like this, and there's an arc. But to do that arc, we would need an x of t and a y of t parametric equations. The math gets a lot harder. Coming back. So we're throwing it straight up. It's coming straight down. All right. All we have to do is say it's a positive 64 feet per second. So is it going to eventually come down? Yes, but technically what's the situation is being thrown upwards first, 64 feet per second. Okay. And then hopefully the other thing you guys wrote is the position function, right? S of t? Physics people. We will see why that equation is what it is, but I don't want to talk about why it is because in calc we don't just memorize equations. 1/2 at squared plus b sub naught t plus x sub naught. We don't memorize that until we understand where it comes from, so we won't be able to do that until second semester when we integrate acceleration. All right, coming back. We might see a little bit further. That's it, right? We have feet per second, we have our units, we have our initial, we have our building, and we have our equation. Letter A says, how long is the water balloon in the air?
Okay, T. So just
Find T. I like it. How long? Find T
when S of T equals to 0, because it won't have any more height.
when x of t, which is the height off the ground, equals 0. Do you guys agree with Sean? Because when the water balloon is on the ground, what is it no longer doing?
Moving.
Moving. Well, it's flying, but yeah, we're done. Right? Especially if it's an 80-foot building, he's not surviving that. Unless he like put a little drop of water. Boop, and it's one of those like fun ones. Anyway. So anyway. T. How long? Find T. You guys have to be careful of this. How long? Find T when the water balloon is in the air. So figure out when the water balloon's not on the air. When it's on the ground, it's 0. So what do? Solve. You want to take the equation from above? We said 0 equal to the position, which is negative 16t squared plus 64t plus 80. If you were super cool, you could solve this by hand, perhaps, with the quadratic formula. We could pull out a 16 first.
From E?
Isn't that going to be 5?
Yeah. So we would have t squared minus 4t minus, oh hey, that's not that bad, you guys. Thinking it was all scary. If it was scary, if it was a decimal answer, you would be going to your calculator, you would be graphing this function, and you would be finding the 0 from your calculator. Does that make sense? Graphing calculator handbook, find the 0, go left, go right. But since this one is a little bit easier,
Back to that.
don't I get t minus 5 and t plus 1? Wait, so it splats on the ground at 2 different times?
No,
Negative
you have to
1.
choose the one that's real.
Yeah.
Kind of silly.
It's negative 1 second, you can't have a negative 1
Yeah,
second.
at negative 1 second, you were still holding very carefully the water balloon at the top of the roof against the railing because you're being safe, right? You're still holding the water balloon at negative 1. It's not even in the air yet. Time didn't start counting until you threw it. So negative 1 makes no sense in context of the problem. What's the only one that does make sense? 5. And how are we going to answer the question then? How long?
5 seconds.
5 seconds. Put those units. Believe it or not, sometimes on an AP, a long answer, you get a point just for putting the units. Sometimes you get a point for putting the units of the entire problem, but still, you don't want to lose that. Makes sense? Letter C.
B. Point.
B, sorry. I don't even know where my mind is. Letter B. What is the velocity of the water balloon when it hits the ground? Now pause. Pause. People that don't really know physics too well. If it hits the ground, what would the common mistake be? For people to be like, oh, it hit the ground?
0.
0!
No.
Pause. If something hits the ground at 0, nothing will ever go splat. Because if you're hitting the ground with a 0 velocity,
You're not
if you're hitting the ground with a 0 velocity, there is going to be no impact. Okay? What causes an impact? If I was to, right now, trip and fall, would it kind of hurt?
Yeah.
Yeah. But if I was to go on top of the gym, trip, and fall, would it hurt a whole, well, it would hurt a whole lot.
Well, it depends. Are you like on
Pause. I survived the fall.
Okay.
Will it hurt?
Yes.
Why?
Because the
Because
Because of the extra height, I'm going to have extra velocity at the moment I hit the ground. Okay? Yeah, right. So, pause, come back. So, long story short, if you hit the ground, will your velocity ever be 0? No. What is 0? Your position. You are on the ground. You are at the ground.
That's so sad.
Well, hopefully it sticks, because every year it doesn't stick. And I haven't used that example before, so hopefully it works. So, ready? If you're at the ground, if you're hitting the ground, the position is 0, but the velocity is something. Because that's what makes the water balloon go splat. So, how do I find the velocity of the water balloon when it hits the ground?
And then you can run.
Well, you have to solve for what?
I need to
Final
plug in.
velocity, which is
0.
I need to plug in not 0,
Well, 5.
5 seconds. When is it at the ground? Yeah, so I need P and T first of all. I need to figure out who velocity is. Oh, hey, according to our page, isn't it the position prime? And then I'm going to plug in 5 seconds and say, what is the velocity at 5? But before I can plug in 5, I need velocity. Where's my function? Nope. Where's my function? I need to derive to find it. So I take the derivative of position, I bring down the 2, negative 32t, plus I bring down the 1, 64, t to the 0 is gone, and the derivative of any constant is 0. That's my velocity function. All I have to do is plug in 5 seconds.
Because it's
Oh, I bring down the 1, 1 minus 1 is 0, and then it, yeah. So I plug in my 5. If you guys notice, the ball was still going upwards until, can anybody figure out when the ball stops going up?
When vertical velocity is 0.
At 2
At 2 seconds.
Yeah.
Because if it's at 0, it's still a positive. If it's at 1, still a positive, 64 wins. But when it's at 2, what's my velocity?
It's
0. And then at 3, it's going to be a negative. So what happens in physics? When you throw something up, it has a positive velocity. It's going to have a negative velocity as it falls, but what must be by IVT between a positive and a negative? What must happen? What must
There must be a
happen?
point where
A
it's
0, which is why in physics, when you throw something up, before it starts falling, it has a momentary stop. It momentarily stops at the peak of its curve, at the peak of its path, which is kind of interesting if you think about it, because do we see things stop? I don't know. Do we?
Technically, no.
It's instantaneous, so technically we don't see it. It is so small, but it is interesting. Well, did you see that maybe? Yeah.
Whoa, Sarah.
But how do we know it has to stop? IVT. Go team. So will you guys plug in what's negative 32 times 5 plus 64?
Oh, I don't know.
It's negative
Is it 96?
Negative 96, yeah.
Yeah.
Double check, am I right? Because that would be 150, 160.
Yeah, it seems right. Because that's
Take away
so
60,
it's
take away 4.
just 32 times 3 is 96.
Yeah.
You would have got the same answer if you had thrown it down.
Interesting.
No. That's just how it works with no air resistance. Smiley face.
That's random. Go team. What else we got? All right. So, free falling objects in a rectilinear model, which don't worry, that's all we're going to see in CalcAB. Free falling objects in a rectilinear model. Sean, pass me this back. Can you read the name that is now? It's someone in my
No.
class. Is that Lucas Dow?
Yeah, that would be Lucas Tower.
Can you find it at some point today? Thanks. I'll send a picture of it. So motion problem solving clues. We've done a lot this section. Let's go ahead and summarize some of it. Steve, we haven't talked about velocity and position. Hold on.
Oh, that's kind of important.
Yeah. I do have clues, but I want to go ahead and pause really quickly. Kiddos, right this second, I'm going to your class folder, and I'm going to class notes.
This class is so quick.
I know.
Okay,
Why is this
It's because of little things like Tyler's hair. It just makes it fly by.
It's from like 8th grade. Mine totally doesn't.
Okay, if you guys have a phone, I want you to grab it out. So I'm going to have you take a couple pictures really fast, okay? In the class notes folder, okay? In the class notes folder, have you guys realized that there's something called forever cards?
Yeah, well, I didn't know that, but.
Okay. There's something called forever cards.
Can you
Now,
copy them all down?
the forever cards, well, here's the problem. Year to year, there are some changes. Year to year, there are some changes. I'm going to your guys' folder as well. CalcAB, class notes. Okay. If it comes up. Struggle. Okay. Struggle. Come on. You guys are killing me. Not you, the computer.
But it's okay, because I have physics afterwards, and physics is fun later.
Alright, if you guys go to your forevers, updated past, where are we at? Forever 9, Forever 10? I'm going to, and we're going to write down in notes tomorrow, but you can look on your forevers and get them in your cards. There's going to be one card for the basics of motion. There's going to be one card for the problem solving clues. Like, go ahead and back up, start walking to the ground, or walking to the door. Like, if you're hitting the ground, position is 0. If you have an initial velocity, it's v of 0, things like that. Alright, cool kids, I'm sorry, I'll see you guys later.
Misty, I think I'm your only physics kid in regular Cal.
I know, I think so. Trevor's my only one in period 6. And then you're in period 1. But I still refer to you because I want you to know that. And you should know things like that, formula 1/2 AT squared.
I was asking, we need to have like 10 thoughts.
Lunchtime.
So it's not, well, because I'm just asking because like people come, so like,
Oh, I'll just close the door. I'll
alright,
put a note
so
on
I'll,
the go back later.
I see. Because
Or period 7. We could do that too.
Yeah.
We could go out on the tables or something.
Christy, is gravity in feet per second -32?
Yeah, or maybe 9.8.
That's such a weird number to me. I don't
But the
know.
funny thing is gravity is different depending on your location on the earth, but we don't know that.
Well, yeah, but not by too much.
Yeah, not by too much.
Hey, pre-cal kid, let's go get that pre-cal.